what is a polynomial? Okay, a polynomial is an expression with many terms. Okay, that's all a polynomial is. It's just an expression with many terms. Now, if you look down here, you have 1, 2, 3 terms in this polynomial here. There's 3 of them, called a trinomial. Okay, 1, 2, 3. There's 3 of them there. They all are different terms because they all have a different variable or no variable with it. Okay, now we are talking today about adding and subtracting these polynomials. Okay, now the first step with polynomials is to eliminate parentheses, okay, by doing our distribution rules. Okay, that's been the first step with all of problem solving this entire semester. Step 1, get rid of the parentheses. The only way to get rid of parentheses is with distributing, and we've been doing that since the very beginning, whether it's exponents or whole numbers. Okay, second, the second step is to combine like terms. I'm putting a star on that because that's essentially all we are doing, is we are combining like terms. That's it. You already learned it, didn't you? Okay, we are combining like terms. Yep. Congratulations. Now, when we combine like terms, okay, now I know this says 3 and 4, okay, but these are like little subsets of combining like terms, okay? So 3, okay, we are going to eliminate any and all 0 pairs, aka when we combine the like terms, it adds up to 0 or subtracts to 0. If our answer is 0 when we combine them, then they are 0 pairs, which means they are eliminated. Okay, we will then combine all variables of the same degree. And I'm going to put in parentheses here, degree is talking about the exponent. The degree is the exponents. You know how when you talk about the temperature, you have that little degree sign? Okay? Like this morning, I got in my car, and this is what my car read. Do you see how that little degree is right there? Do you see how it's in the exponent spot? So in math, we call that the exponent. The other term for it is degree. These are just synonyms, okay? But that's all it's talking about, okay? Now, part 4, which is the final step, is you are going to rewrite in standard form by listing in descending order. And we are talking about descending degree order. So the higher exponent will go first, then the next exponent, then the next exponent. Okay? Now, standard form. What does standard form mean? In simplest terms, all variables on the same So if we put an equal sign, all my variables better end up on the same side. That's what standard form is. Standard form is just all variables on the same side. That's all it is. Okay? Yes, sir. So if we look at the first example here, okay, there are 2 different ways that we can combine like terms. This is one strategy to do when combining like terms, is to stack it like a normal addition or subtraction problem. That's one strategy. Okay, you don't have to do that strategy, but that's one way of doing it. Okay, the important thing is to make sure when we are combining like terms, we are looking at the variable and the exponent. Whole numbers will change based on what we are combining. The variable and the exponent must stay the same. So this x squared goes with that x squared. This x goes with that x. This non-variable number goes with the non-variable number, aka the constants. Okay. and we literally just combine them. Now, if I have no number in front of a variable, what do we assume is there? 1. So technically, what I have here is 2x squared plus 1x squared. So I have 2x squareds. I'm adding one more x squared to it. How many total x squareds do I have now? 3. I now have 3x squareds. I have 3 x's, but I am, if you look here, adding negative 5 x's to it. AKA, I have 3 and I'm taking away 5. What do I have remaining? I have negative 2 x's. I'm going to scratch these out because I finished them. Same thing here, but this time I have 2 constants, but I'm taking away 5. How many constants do I have now? Negative 3. I have now combined all like terms. Are there any other like terms to combine within my answer? No. So guess what we do? We box it in. And that's it. That's your answer. That is correct, Dwayne. So Liam has asked, what about these x's? This one has a squared. This one does not have an exponent, so they are not similar terms.
That's all you do? You subtract them. If they're not similar, add it and add. That's crazy.
If they're not similar terms, then you do this.
Is that like
they're mixed match, like the partners, like they're
Problem number 3. Actually, problem number 4. Problem number 4. Okay, problem number 4. Oh, 4. I looked at 3. Okay, so here I have this polynomial minus this polynomial. It's still combining like terms. However, I don't like the minus sign there, so I am going to actually distribute that negative to everything on the right-hand side parentheses. Now, with me doing that, I am basically making this entire thing one giant problem, okay, when I distribute that negative. So really what I have here is I have 11m squared plus 2m minus 11. Negative to a positive now becomes a minus 5m squared. Negative distributed to a negative makes that a positive. Same thing, negative to a negative makes that now a positive. So once I got rid of that minus sign, distributed it to the right-hand side, okay, it basically eliminated all parentheses, which is what we want. We don't want parentheses. We want to get rid of them, okay? Now we just combine like terms. Coach Kimball's strategy, there are 2 ways you can do this. You can have multicolored pens or pencils or highlighters. That's one way, okay? Or you can do the underline method if you have one singular thing to write with, which I currently have just one thing to write with. So for the first thing is I'm going to find the highest exponent, which is 2, and I'm going to see, is there any other terms that have an exponent of 2 and the letter m? Which one? Negative 5, okay? Now, if I take 11 and I am combining it with negative 5, what do I have? Correct, Daniel. I have 6m squareds. I like to scratch them out once I'm done with them so I don't look at them again because my ADD brain will keep fixated on it. Next is the next exponent, which in this case is to the power of 1 or no exponent shown. I have 2m, and I am combining 6 to it. How many m's do I have now? Positive 8 m's. Done with them, so I scratch them out. I have negative 11 combined with 17. If I have negative 11 and I add 17 to it, I have positive 6. Do I have any other like terms to combine? Have I combined all like terms? So what do we do? Box your answer. Simple as that. Now, the reason why I skipped 3 and 2 is because I now want you to go back and do 3 and 2 on your own, and then we will spin the wheel of not ideal again for people's answers. So again, we are working on 2 and 3, example 2 and 3. Then we will spin the wheel. You get a maximum of 2 minutes. That's it. And if you're not back in 2 minutes, then we have consequences, aka a write-up. Because you have a history of being gone for 7 minutes at a time. That's for him to figure out. Oh, that's for him to figure out. My answer's not changing, Sam.
I guess you're supposed to just like stop and wait.
You're supposed to be doing question 2 and 3.
I'm done.
Great. I can't wait for the wheel to spin. Yes, Corbin.
If they're the same, do they just cancel out? Like this one? No.
So if you do -3 plus 3.
0.
Now, do you have to write 0? Remember, if you get something that creates a 0 pair, it's gone. 0 pairs cancel each other out. I need AC.
That's like saying 1 minus 4. If they're 1 minus 4 is these are both constants, right?
Yes, sir.
Says 8 x y. Is the y different so like if I was adding 5 x y plus 8 x y, 13 x y.
If it's a minus sign, you're going to have to
When you are done with questions 2 and 3, if you can do me a favor and just put your pencil down. Just push the door, Carlos. You have the same rule. Maximum of 2 minutes.
I think Carlos would have enough time to get it. I bet Carlos would have
It's going to stay in the 60s all day. Plus 6 is what?
It's a high of 71 today.
Wait, how do you figure out what your average is in the class?
What is negative 11 minus 7?
X2.
Okay, so that whole thing measures. Okay, try it again, Meg. I started the wrong one, didn't I? Okay, thank you. Negative 7, negative 11 plus 7 is 46. Okay, so that, is that what you got? If 5 mile wind speeds.
Did you just get that watch for Christmas?
I got this one for Christmas too.
Not for Christmas, but
Oh, it's someone with a real diamond.
okay, so this one, because it's a plus sign, you ain't gotta change that, right? Because if I distribute all these, if the signs are not changing, now you can just go ahead and start applying your like that, that, that. Okay, so we're gonna add these. We're gonna add these.
All right, well, Mr. Barker is helping Kinsey out there to finish off. We are going to go ahead and spin the wheel.
What numbers are you
2 and 3, Carlos. Better hope you don't get picked.
so that with that whole term, you cancel out.
Yeah, I don't know how to do this, coach. I hope it's
Pedro. Number 2, please. I circled them.
Hopefully it's not me. Dwayne.
Santiago.
Number 3, Dwayne.
I mean,
Go ahead and go up there, Dwayne. There's enough room for both y'all to be up there.
I can help you out.
No, Sam.
Wayne with the blue diet.
Thank you, Pedro.
You should buy cold brew. It's only $20 right now.
Correct.
I could have game pass.
You're missing something there, Pedro. Pedro. The X connected to what? Are you sure about your last one, Pedro? Think about it.
And I tried to return it, but it didn't.
-4 minus. Dwayne, you can just write your answer, you know, right? Ah, explains that. Okay, get it. I understand.
Wait, Pedro, how'd you get plus 3x? It's a negative 3. I mean, no, it's a negative 3x.
For number 2, isn't it?
Yeah, the second number should be a negative 3.
What Pedro has up there is correct.
Yeah, that's negative.
What Pedro has up there is correct.
But I'm asking.
What Pedro has up there is correct. What Pedro has up there, Sam, is correct. We'll explain it. Just give us a second. Aw.
Pretty sad.
How many pages are you?
Only during independent work. You can do it, Dwayne. You have 1 minute.
Pedro, I'll go up with Pedro. I'm going with right here.
Coach, do you have an advisory or not?
There is no advisory today. Tomorrow, yes.
You make your nose big.
You can do it, Dwayne. There you go, bud. All right, so looking at number 2. Okay, looking at number 2, Pedro has up there 1x squared plus 5x minus 5. That is the correct answer for number 2. One of the biggest things that you need to make sure you do in order to get these problems correct is to distribute that negative. Get that negative to everything on the right-hand side. So now really what we have is 2x squared plus x minus 4. And down below, we now have negative x squared plus 4x minus 1. So that's what we have now. You got to distribute, got to get rid of parentheses, okay? So when you distribute that negative to everything to its right, now this is what you have. Now you can just go down the list. 2 minus 1 gives you just 1x squared. You don't need to put the 1 in front of it. You won't get it wrong if you do, okay? 1x plus 4x's give you a total of 5x's. And then negative 4 minus 1 gives you negative 5, okay? Yeah.
Since you distributed that negative to negative 4 turns to positive.
Correct.
Oh, that's the negative.
No, think about, remember, when you distribute, you multiply. So negative times a negative is a positive, okay? Question number 3, Dwayne, even with my glasses, I am still struggling to read that first number. What's the first number say?
10x
Squared?
squared y squared plus 13x y.
Perfect. That is correct. Now, as you can see, Dwayne went ahead and distributed his positive, which essentially won't change anything except get rid of the parentheses, which is what we want to do, get rid of the parentheses. Then he combined all his values, and he got 10x squared y squared, which is correct on that one. Then he got 13xy, which is correct. And then he noticed that the negative 3xy squared got eliminated because the other xy squared was a positive 3, and negative plus a positive 3 gives you 0, which is a 0 pair. Cancel out. We don't even need to write plus 0. It's just gone. Any questions, comments, or concerns about that? Fantastic. Turn to page 2, please. You may now use the restroom, Sam. You still have 2 minutes. Hurry up, Sam. Your time is now 1 minute 45 seconds just because you decided to try to get a high five from Ace. Now you have 1 minute 35. Now you have 1 minute 25. Yeah, I know. All right, so moving on to page number 2. One of the biggest things that we need to understand is the first step that we need to do. Step number 1, and one of the most important steps, is eliminate our parentheses. Eliminate the parentheses. Distribute, whether it's a positive or a negative, first. Eliminate the parentheses. Okay, so here, question number 7. I have a positive. I'm going to distribute that to everything in this parentheses here. I have another positive, and I'll distribute it to that parentheses there. Now, when you distribute a positive 1, does that really change anything? No, it doesn't really change anything. However, what are we eliminating? The parentheses. So we don't want the parentheses there anymore. So I have 3x squared minus x squared plus 4 minus 4x plus 2x squared plus 2x. Now I just have this one giant problem. When we get to this one giant problem, my biggest thing and what I need to make sure that I do is I need to then simplify by combining like terms. Now, when we combine like terms, the variable with the highest exponent will go first. In this situation, what is the highest exponent? What is the value of the highest exponent? 2. Okay? The value of the highest exponent is 2. So that's going to be the first set of numbers that I combine. So I have here, I'm going to underline every exponent 2 that I have that has the same variable. And I'm saying there's 3 of them. I need to combine said 3. So I have 3 minus 1. What's 3 minus 1? 2. So I have 2 plus another 2, which is 4. So I have 4x squareds. Eliminate, because I'm now done with that. Are we just... Holy cow. Okay. Now I move on to, because squared was my highest exponent, the next value that I am going to do is just the variables. Okay. So I have a negative 4x and I have a 2x. If I have negative 4 and I add 2 positives to it, what do I now have in my hand? Negative 2. So I now have a negative 2x. Scratch out, scratch out. What is the only thing left over? The positive 4. There was nothing to combine with said positive 4, so I just write it at the end. Now, looking at what I have simplified so far, is there anything else that I need to combine? No. So what do? Box it in. That's it. We are distributing and we are combining like terms. What are we doing here? Good. Distributing and combining like terms. Now, there are going to be times where you have a value outside of the parentheses. I'm going all the way down to number 11. Go ahead to number 11. There will be times where you have a value outside of the parentheses that you'd have to deal with. Does our steps change? No. Step 1 is always in problem solving is eliminate your parentheses. How do we eliminate parentheses? Distribute. I'm going to distribute that negative 2/3 to everything in the parentheses. Thank you, Ace. Now, when I distribute Okay, this negative 2/3. I'm going to rewrite my entire problem here. I have 9q squared. Negative times a positive is a negative. 2/3 of 3 is 2. Okay, negative 2/3 times a negative 7 will give me a positive, and it will actually give me a positive 14 over 3. And then this was not in the parentheses, so I just rewrite it. Any questions of where I'm at so far? Does everyone understand what I just did? Yes. All I did was I distributed the negative 2/3. I have been doing math for a lot longer than y'all, so I just know how to distribute that fraction a little bit quicker, so I just kind of moved on in that pace. Okay, so that is that for that one. All right, now that I have gotten rid of my parentheses, what is my last step that I need to do? Starts with a C and it rhymes with combine like terms. We're now going to combine like terms. Now, when I combine like terms, I'm going to find the highest exponent first. What is the value of the highest exponent in this problem? Huh? Sorry? Stop looking at the whole number. I'm saying highest exponent. Squared, right? So that means I'm going to find everything that has a square to it. So that combines to a 9 plus a 5 gives me how many total q squareds? Pretty sure 9 plus 5 is 14, Daniel. Okay, so I cancel that out. Then I go to the next best thing, which is just the variable. Is there any other like terms with that negative 2? No, so what do? You just rewrite it. What about the 14/3? Is there anything with that? No, so I just rewrite it. Did I change that improper fraction? No, I just rewrote it. Nothing left to combine, so there's my answer.
Wait, do number 8.
You want me to do number 8?
Yeah.
I'll do number 8 quickly. Jackson, I want your head up. Okay? So that's just an example that sometimes you're not just going to have a plus or a minus outside the parentheses. Sometimes you'll have to distribute an actual number. Okay? Now I'm being asked to do number 8, so we'll do number 8 very quickly because it is a quick answer to do. First and foremost, get rid of the parentheses. So I need to take this negative here and I need to distribute it to everything to its right because it is in the whole number spot, so it distributes to its right. Exponents distribute to the left. Whole numbers distribute to the right. So I'm going to now have x minus 3x squared plus 1. I am losing these parentheses, Sam, because I'm doing distribution. Okay, once I distribute this negative, I now have a negative 7 minus 2x squared.
Oh, you just
When you distribute just a negative, it's like multiplying negative 1 to everything. It just flips the sign.
What if it's a positive?
Then nothing would have changed.
What if
If I take a positive, let's like right here, good example is number 10. I take that positive and I distribute it. 4 times positive 1 is still 4. It doesn't change. Okay, so moving on, keep finishing this one. Look at my highest exponent, which is a squared. So I combine those. Negative 3 plus negative 2 is negative 5x squared. Done with those.
you combine it if it didn't have the exponent? I mean, if it didn't have the thing in the air?
The thingy there.
In the air.
The squared, I would not combine the negative 3 and the negative 2 if that negative 2 did not have that squared. Okay? Then I have just x, so I'm going to add x. Then I have 1 and negative 7, which would give me negative 6. Okay? Questions, comments, concerns about that? Okay? Now, a little bit of application, because you will have some problems on it about this. Okay? Application represent the perimeter of the following shapes. There will be times when I give you shapes on a quiz, homework, test, and I ask you for the perimeter. When you are finding perimeter is found by just doing what? Thank you, Renata. Adding all the sides. Perimeter is add all sides. Now, when we add all the sides together, what are we essentially doing? It starts with a C and it rhymes with combine like terms. We just combine like terms. So I'm not going to do 13 just because I don't want to do it. 14 has less sides, so it's a little bit quicker to do. But I'm going to take this side plus this side plus this side. I'm just going to add them together. Literally, 2x squared plus 8.
How do you
plus 9x plus 4x squared plus 4x minus 2. Literally add the three sides together.
When you find area, do you also find the one in the middle?
What am I asking for? Perimeter. Only worried about perimeter today. Okay? So all I'm doing is adding the three sides together. So now I just find the common terms. Boom and boom right there. That gives me a 6x squared. Done with that exponent. Now I can take the x's here. 9 plus 4 gives me 13 x's. Done with that. Done with just. Then I have the 8 and the negative 2, which would give me a positive 6. We are just combining like terms when we ask for perimeter. Questions, comments, concerns, tribulations, or Hinkle
What
pains?
about this?